This lesson is entitled Higher Order Derivatives. Now, in an earlier lecture, we determined that if you were given s of t, where s is distance and t in time, we could find instantaneous velocity. And we used that fact later to develop the definition of the derivative. So now we can say that s of t equals 3t squared, which is distance in terms of time. We can now find the instantaneous velocity by finding the derivative. That is s prime of t, in this case, would be 6t. And so that is the velocity. Okay. Now we can use the letter v, or we will here use the letter v for velocity, so we can say that s prime of t is v of t equals 6t. And of course, the nice thing about being able to find the derivative is now we can find instantaneous velocity for any t. For example, if t is 2, in this case, the velocity v of 2 would be 6 times 2, or 12. Now, if you take the derivative of velocity, that is v prime of t, in other words, v of t is velocity. If you take the derivative velocity, this gives you something called acceleration, which we've indicated here is a of t. Now, another way of describing this is to say that acceleration is the derivative of s of t. Okay? The derivative of s of t. And since it's the derivative of the derivative, we will refer to this as the second derivative. And the notation we will use is s double prime of t is acceleration. In other words, s of t is distance, s prime of t is velocity, s double prime of t is acceleration, or v prime of t is acceleration. So carries several handles there, but that's not going to be difficult to keep straight. Other notations for the second derivative are, depending on how the function is given to you, if it's given to you f of x, then the second derivative is f double prime of x. If it's given to you y, then it's y double prime. And we said earlier, we haven't used it a lot at this point, but another notation for the first derivative is dy dx. And so a notation we'll be using for the second derivative is d squared y over dx squared. Yes, that's d squared y over dx squared. There's not an error here. This is not, you might think it should be d squared y over d squared x, but it isn't. Or dy squared over dx squared, but it isn't. It's d squared y over dx squared. This is correct. We will later in the course share with you why that notation is written in that way, but not in this lesson. Now, we'll use the second derivative other times in this course, so the process is not just restricted to finding acceleration. Okay. In some courses, it's necessary to find higher order derivatives, that is, third derivatives. That's the derivative of the second derivative and fourth derivatives and so on. But we're in this lesson, we'll be limiting ourselves to the second derivative. Now, before we proceed to working some problems, let us flag a warning here. You have to find the first derivative in order to find the second derivative. So if you make an error in the first derivative, you're doomed to make an error in the second derivative. Okay, so what we're saying here, you must use caution and make sure you've taken the first derivative correctly, or you'll go down the wrong path. Finding the first derivative in this lesson is pretty simple, but finding the second derivative can get very involved, and we will see that again later in this course. Let's take an example. F of x is x to the fifth. Find f double prime of x. Well, we're given f of x is x to the fifth, so the first derivative, we know how to find that. That's 5x to the fourth, power rule. Now, the second derivative will be the derivative of this, which will be 5 times the derivative of x to the fourth. So that's 5 times 4x cubed, which is 20x cubed. But you're probably thinking that's not too bad, and you're correct there. Let's look at example 2. F of x is minus 5 e to the x. Find the second derivative. Well, the derivative of minus 5 e to the x is minus 5 times the derivative of e to the x, but the derivative of e to the x is e to the x. And so the first derivative is minus 5 e to the x. And the second derivative is also negative 5 e to the x. That's interesting. We wanted to show you that there are several occasions. Of course, the e to the x is the only function whose derivative is itself, but many times the second derivative, third derivative, whatever, will loop back to be back where you started, but that's not going to occur often in this course. But at the same time, we wanted to use our two rules, which is the power rule and the derivative of e to the x, the only tools we have for taking the derivative at this point. And here's a combination of those two problems. So we have our summation rule here. If you're taking the derivative of x to the fifth plus 5 e to the x, the first derivative will be 5x to the fourth and 5 e to the x, and the second derivative will be 20x cubed plus 5 e to the x. And so that's just another problem. Now, we could give you a more difficult problem. We could take the derivative of a product, and that would be a little more involved, but we'll save that because it's coming up in a soon-to-be lesson. And so rather than spend our time doing that, what we really our thrust here is to let you know that there is something called the second derivative, and tie it in with some of your sciences, in particular physics. The first, if it's distance versus time, the first derivative is velocity, and the second derivative is acceleration. We leave you with one last problem. What if we're given s of t is 5t cubed, and we have two problems here. Problem A, find v of 3, and B, find a of 3. Well, v of 3 means find the derivative, find s prime of t, and then when t is 3. So that's what we'll do. V of t is s prime of t, which is 15t squared. So v of 3 is 15 times 3 quantity squared, which is 135. Then we want a of 3. Well, a of 3 is v prime of t, or s double prime of t, and that's going to be the derivative of this, which is 30t. So that's so a of 3 is going to be 30 times 3, or 90. Now, you don't want to show all of this. You don't want to say a of t is v prime of t is s double prime of t. All we're trying to show you is acquaint you with or remind you of the hierarchy of the fact that this is the first derivative of this and the second derivative of this. These two are joined from our way of thinking. So this is a very brief lesson, and wasn't meant to be any more than to let you know that there is something called the second derivative, but we do want to restate the fact that you need to be careful when you take the first derivative before taking the second derivative, or you are doomed for trouble there, because you cannot get the correct second derivative with the first derivative being incorrect. So we won't beat that to death. And so this concludes this particular lesson.